Okay, so today's lesson has to do with permutations, okay? And permutations have to do with different orders, okay? So we talked about lining people up, and we found that when you line people up and you look at all the different orders, that if you had 7 people, okay, if you had 7 people, and you wanted to find all the different ways, you could have 7 ways for the first person, but once you establish the first person, there's 6 left over. 6 ways for the second one, but once you establish a person, there's 5 people left over. So then once you establish a 5th person, there's 4 people left over. Once you establish your 4th person, there's 3 people left over. Then you have 3 choices, then you establish your 3rd person, there's 2 ways, only 2 people left over. And finally, the last one picked, there's only one way to do that, okay? And that's called a permutation. But we use a factorial button, 7 factorial, and that is 7 times 6 times 5 times 4 times 3 times 2 times 1. But we learned that there's a factorial button in our calculator to make this a little bit easier. So if I go 7, go to math, we find the probability button, and there's our factorial, right? 7 factorial, we get 5,040. Okay, and that's all the different ways, combinations, in order to line up 7 people. Okay, now, in the next example, they say, okay, here it's just easy. So if you had the letters T, R, Y, how many ways can you rearrange those? Okay, so then you can put the T here, T, and then you've got the R there, but if you looked at them, there's only 6 ways. Well, okay, we can write all 6, but we know that it's also the fact that you can do it as 3 factorial, or 3 ways, and 2 ways, and 1, okay, which makes 6 different ways. Okay, now, sample 1's a little bit different, okay? Sample 1 because numbers can repeat. Numbers can repeat. So how is that different? Well, a high school assigns each student a 4-digit identification number using the digits 0 through 9. Digits may be repeated, but the first digit may not be 0. Okay, so let's figure out. We got 1, we got 2, 3, 4, okay? Now digits can repeat. So if I use, for instance, a 6 here, I can use a 6 again here. This makes it different because when we did our permutation, we'd pick a person, that person was taken out of the field, okay? This is different, okay? So then how many possibilities, and we can't use 0, how many possible letters can be used, or numbers can be used? We can't use 0, so how many numbers are left?
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 possible choices here because 1 through 9 is possible. Now, we can repeat numbers. So if we use a 9 here, we could use a 9 here, right? If we use a 3 here, we can use a 3 here. Okay, Kurt, put your phone away. So then, how many choices do I have here? 10. Because we can use 0 through 9. There's 10, 0, 1, 2, 3, 4. That's 10 choices. Numbers can repeat. So if I used a 5 here, I could use another 5 here. I could use a 5 again. So how many choices are left here? 10 again, right? Okay, and then how many choices can be left here? 10 again, because I could if you can repeat numbers, then you're just going to multiply. So the answer is going to be, believe it, 9 times 10 times 10 times 10, okay? So if numbers can repeat, it's not a factorial, it's just a multiplication. Kind of like what we did yesterday. It was a combination, right? It's a combination. And we did combinations yesterday where things could repeat, right? I mean, if you had ice cream cone, right? And I liked chocolate, vanilla, and strawberry. And Kay's like, no. I like vanilla, chocolate, strawberry, okay? 2 different ice cream cones, but we both get chocolate. It's not like I get chocolate, and if I choose chocolate, you don't get chocolate anymore, right? That wouldn't be too cool, because I like chocolate, you might like chocolate, but if I get first pick, bummer for you, huh? So if things can repeat, it's a combination. If things can't repeat, it's a permutation, okay? So if we trade, well, you know, there it is. The 9 choices are 9, because you can't use 0. Then you got 10 times 10 times 10, so there's 9,000 possible combinations, okay? So, example 1. Let's go and look at this. Okay, the armed forces of the United States consist of the Army, the Navy, the Air Force, the Marine Corps, and Coast Guard. If the flags of each branch are presented in line, how many different arrangements are possible? So now, can I repeat? Would it be fair to go Coast Guard, Coast Guard, Coast Guard, Coast Guard, Coast Guard? I mean, what do you think the Navy's going to say? So if I establish and put Coast Guard out there, can I reuse Coast Guard? No. So this one's a permutation. Do you see the difference? So if I take a look at this one, okay, so how many flags do I have? 1, 2, 3, 4, 5. I got 6 choices, right? I got 6 choices. So what am I going to pick?
Isn't there only 5 because Air Force is 1?
1, 2, 3, 4, 5. Thank you. Thank you. Thank you. Thank you. So there's 5 choices, right? So there's 5 choices. Let's pick one. So boom, I get 5, right? Okay. And then what? I pick 1, and then how many choices are left?
4.
And then I pick 1, how many choices are left?
3.
And then I pick 1, how many choices are left?
2.
And then,
1.
so this could be 5 factorial, right? So you could use your calculator and do 5 factorial. You could just multiply. How many kids think it's just easier just to multiply, right? I mean, you could go 5 times 4 times 3. It's just as easy on your calculator as going 5 factorial if you just went 5 times 4 times 3 times 2 times 1, right? 120. Or if you used your factorial button just for the heck of it, you went 5 math, probability, factorial, boom, boom, 120, okay? Both work, right? Both work, okay? Now, number 2, 11 offensive starters on the football team line up on the sidelines during the pregame. In how many different ways can they line up, right? So what do you think it's going to be? What do you think it's going to be? Would you go along with 11 factorial? Because once we put Kurt up there as your first starter, Kurt can't play all the positions. We can't duplicate Kurt. Kurt can't repeat, right? You can't repeat. That would be silly, right? So 11 factorial, that's a pretty big number, isn't it? Let's see how big. Now, in this case, I might want to use my factorial button because I'd have to go 11 times 10 times 9 times 8. Kind of tedious, right? Type blah, 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 blah. So if I just go 11, math, factorial, right? That's a big number. So there is 3, 9, 9, 1, 6, 8, 0, 0. 39 million ways to line them all up, right? That would take us all season to line them up, right? We got better things to do. Okay, now, number 3. So the United States Service identifies states and territories of the United States with codes consisting of two capital letters, okay? 58 codes have been assigned, okay? How many 2-letter codes are possible, okay? 2 capital letters. Could I use A? Could I use B? Could I use the letter C? Could I use the letter D? Could I use E, F, G, H, I, J, K, L? How many letters could I use? Could I use 26? So for sure I have 26 possible letters, right? Now, could I use the same letter again? Yeah. They don't say no, right? Could I use A again? Could I have an AA? Probably. They don't say I can't. Could I use a BB? So how many choices do I have for the second one? If I can I use A? Can I use B? Can I use C? How many choices do I have for the second one? So isn't it just 26 times 26? And what is 26 times 26? So I'd have a total of 676 possible choices, okay? Okay, how am I doing? All right, finally, we're almost there. Number 4. How many possible 3-letter arrangements? 3 letters, okay? So, I got to use P-A-R-T. So first, how many choices do I have for the first one?
4.
Okay, so I got 4. Now, can I repeat? No letter may be repeated. So if I pick the P is done. The P gets removed. It gets put in a spot. How many choices are left? 3, right? So they can't be repeated. So let's say I pick the A. How many choices would be left? 2, right? And then if I pick the R, then how many choices are left? Just 1, okay? So if it made...
Isn't it a 3-letter arrangement?
It is. So you know what? We don't pick that one, do we? Doesn't change it though, does it? Right? Good question, Katie. Okay. Now, permutations arranged are at a time. Okay, now how does this work? Okay, so let me give you an easy example. They didn't give you this is a bad example, but I'm going to give you a better example. Okay, let's say that we have. Let's say we have. I want you to write this down. 8 kids, right? And we want to line up 5. Okay. Okay, we want to line up 5, okay? So, 8 kids. I'm going to go line up 1, 2, 3, 4, 5, okay? You ready? How many choices do I have for the first kid? 8. Okay, so boom. Katie's up. She's out of there. Okay, now I've got 7 kids standing around, okay? How many choices do I have for the second position? Okay. Okay, now boom, I pick Kurt. Kurt's up there, right? Okay, now how many kids do I have left? 6, and then 5. Now the other kids, too bad for you, go home, you don't get picked, right? Right? You agree? So there's less combinations. So we can go 8 times 7 times 6 times 5, okay? So, but there's a formula, okay? Now, they give us this formula here. Ours is going to be, ready? Ours is going to be 8p5. Why don't you write that down? We have a total of 8. We're only going to pick 5. We have a total of 8. We're going to pick 5, okay? So our formula should be this. Okay, check this formula out. We're going to go 8 factorial over 8 minus 5 factorial. Now, this is just a formula because obviously we would do it differently. There's so many ways to do probability. Sometimes teachers make probability hard because I would have been, that's it. I would have gone 8 times 7 times 6 times 5 times 4, okay? But sometimes the numbers are so big that we might need a formula, okay? So what is that? That's then 8 factorial over 3 factorial. You okay with that? Okay. Which would be, and I'm going to write it out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's my 8 factorial, right? Over 3 times 2 times 1. That's my 3 factorial. That would cancel with that, that would cancel with that, and that would cancel with that, and guess what we have? Exactly what I wrote up there, right? Exactly what I wrote up there, okay? Now, why is that important to show you that, okay? I'm almost done, honest. Go back to your math button, go to probability. And what do you see right there? Well, you don't see anything right there. What do you see right there?
Yeah.
So if I were to use this button, I'd go 8, go math, probability, boom, and then I'd go 3, nope, I want to go 5, right? 5, there it is, which is what that times that times that times that. And we're going to come back to this. If I totally lost you, don't worry, I'm going to come back to this, okay? So what I like about this particular book that we're using is spirals. That's what I like about it, okay? We're going to talk about this some more. Okay, so homework, you ready? I'm going to give you homework. It's another sheet.